In this video, we're going to look at an example of minimizing cost. So we have a base of an aquarium with a given volume is made of slate, while the sides are made of glass. So we're saying that the slate here costs 5 times as much as glass does per unit area, and it asks us to find the dimensions of the aquarium that minimize the cost. All right, so let's suppose that we have the X, Y, and Z here denoting the dimensions of the box. It's a rectangular box aquarium. So the volume then has to be V. So when we multiply X times Y times Z, we have to get V. We're going to solve for one of the variables in terms of the other. Let's just solve for Z. Z equals V over XY. We want to minimize the cost function. Well, the area of the base is X times Y, and the area of the sides will be X times Z and Y times Z. We know that the base is 5 times as much as any of the sides. So we'll have a 5xy, that's the only thing on the base, but we have two sides that have xz as an area and two sides that have yz as an area. Plugging in our formula for z that we just found and doing a little bit of simplifying, we get our function of two variables is 5xy plus 2v over y plus 2v over x. Take our first partials here. We get 5y minus 2vx over x squared for the partial with respect to x. We get 5x minus 2v over y squared for the partial with respect to y. We want to know when these are simultaneously 0. So we'll just we'll multiply the first equation by x and the second equation by y. We know that, at least in the context of this problem, neither x nor y will be 0 because otherwise we would not have a written aquarium. So it's okay to multiply both sides by the variable x and the variable y. Subtracting the equations, we get the equation 2v over y minus 2v over x equals 0. That happens exactly when x is equal to y. Substituting x equal to y into the first equation and solving, we'll get x is equal to the cube root of 2v over 5, which means y has to be the same value. We want to make sure we have a minimum here. So we take the second partials with respect to x, the mixed second partial, and the second partial with respect to y. We're putting in cube root of 2v over 5 in for x and y. Notice that the x and the y are cubed here. So when we put that in for our a, to calculate our a, we just get 2v over 5 in the denominator. And likewise, we get 2v over 5 in the denominator here when in our second partial with respect to y. We simplify here. We get 100 for this product because the v's will also cancel. We get 25 here. So we get 75, which is positive. It says if it's positive, the d is positive, and since a is positive, we really do get a minimum. It's the only minimum we found in the entire domain, so it must be the absolute minimum. So the dimensions that will minimize the cost are the x value and the y value we found, and doing our v over xy, we can calculate the z value as well.